The number of retail drug prescriptions in millions can be approximated by y equals 86.87x plus 2,920.24, where x equals 0 corresponds to the year 2000. Find the approximate number of prescriptions in the following years: A, 2007, B, 2009, and finally C says, assuming that this model remains accurate, in what year will the number of prescriptions be? 4,750,000,000. Alright, the first thing that we want to do when we start out with this particular problem is understand exactly what it's asking. So when you read these sort of problems, you want to start from the beginning, and this is the number of retail drug prescriptions in millions. Okay, so already we're saying that there is a certain number of drug prescriptions out there. And then we look further and it says it can be modeled by y equals 86.87x plus 2,920.24. Now, let's explore this for a moment, because this gives us two things, two variables. We have a y, and we need to know what y is, and then we have an x, and we need to know what x is. Well, let's further read the problem, and it says where x equals 0 corresponds to the year 2000. Well, that means that x represents the year. And the 0 year, x equals 0, is going to correspond to the year 2000. Which means that anytime we add to that, let's say the year 2004, I want to know what x would be in this case. Well, if, and this is going to be the key component to this, if year 2000 is represented as x equals 0, and I take this 2004 and I simply subtract the year 2000 from it, I end up with 4. And that's going to be my x. X will be 4. So whatever x is going to represent the number of years beyond the year 2000. Let me write that down. So you'll see that I've written that down. So we know that x is going to be the year beyond the year 2000. But what does that mean that y is going to be equal to? Well, in this case, y is we're going to go back to what we originally said. The number of retail drug prescriptions in millions can be represented by this equation, which means that y is going to be the number of scripts in millions. And when I look at this particular equation, and I'm going to rewrite it down here, y is equal to 86.87x plus 2,920.24, we'll notice that this value is our y-intercept, and this represents the number of scripts in millions in our 0 year, or when x is equal to 0. In addition, we want to look at this number right here, and this is going to represent the slope of the linear equation or graph, and that's going to be equivalent to the number of millions of scripts that we increase by every year. Okay, so now that we've got this sort of broken out, let's go ahead and start with the first part, or the first portion of this, part A. I want to find the approximate number of prescriptions in the following years. A is 2007. So let's go ahead and consider part A. Remember, we're still going to use y is equal to 86.87x plus 2,920.24. And we're talking about the year 2007, which means that x will be equal to 7. How do I know that? Because you need to remember that x equals 0 is represented by the year 2000. And then if I subtract these two, I end up with 7, and that's what gives me x equals 7. So I'm simply going to take this value, x equals 7, and I'm going to substitute that into the linear model or equation that I was given wherever I see an x. In this case, there's only one x since it's linear, and I can go ahead and write down the fact that y is equal to 86.87 times 7, and then I'm going to add to that the y-intercept of 2,920.24, and then I will calculate this. Y is equal to, and so I get 3,528.33, but we have to remember that that is in millions. So we'll go ahead and write that down in millions, and that's the answer that you would submit. But if we were doing it paper and pencil, we would go ahead and say something like this. In 2007, the approximate number of prescriptions was 3,528.33 million. Alright, so now we're going to move on to part B, which in this case, part B is going to be the year 2009. So when we do this, we're going to have to go ahead and calculate what x is. So in the year 2009, remember that we're taking that 2009 and we're going to subtract the 0 year, which in this case is 2000, which gives us 9, and this will be our x. Alright, so we're going to use the equation again, and we will have y is equal to 86.87, and notice that nothing really changes except for this x value. We're going to multiply that by 9, and then we're going to add to that the y-intercept of 2,920.24. And now we can go ahead and calculate this, and y is equal to 3,702.07. So therefore, we need to remember that this is also in millions, and we can write the following. So in 2009, the approximate number of prescriptions was 3,702.07 million. Alright, now we've got the third part of this thing, which states that assuming that this model remains accurate, in what year will the number of prescriptions be 4,750,000,000? So now we go to the third part of the problem that says, assuming that this model remains accurate, in what year will the number of prescriptions be 4,750,000,000? Okay, this is in reverse of what we've been doing, because now we want to find x, which is the year, given y, which is the number of scripts. So we know that in this case y is going to be equal to 4,750,000,000. However, the problem is stated that y is given in millions. So I'm going to need to do some rearrangement of this number. And since y is given in millions, what I'm going to do is go ahead and move the decimal place from right here. I'm going to move it 6 places to the left, because 1 million contains 6 zeros. So that means that this value right here can be written as 4,750,000,000 prescriptions. Which means that my equation, my linear equation that we've been dealing with, is now going to look like this. I'm going to have the 4,750, and that will be equal to 86.87x plus 2,920.24. Now remember, we want to find x, which is going to be the year after x equals 0, such that that's equal to that the year is 2000. So in order to do this, I need to solve the equation for x. Okay, so in order to solve this for x, I need to go ahead and peel away everything so that I'm left with just this value right here. So I'm going to start by going ahead and subtracting 2,920.24 from both sides of this equation. And basically what I'm doing is the order of operations in reverse. I'm going to work my way up. And when I do this subtraction, on the left hand side we'll have 1,826.76, and that will be equal to the 86.87x. Now this equation is still balanced on both sides because I did the same thing to the left that I did to the right. Now I want to go ahead and divide through by the coefficient of x so that I can get x by itself, and dividing both sides with 86.87, I'll have x on the right, and on the left I'll have the following value. And I'm only going to carry it out 4 or 5 decimal places. And it keeps going. It is a non-terminating decimal. So what this means is x is the year after 2000. If x equals 21.06319, basically in the year 2021 there will be approximately 4,750,000, 750 million scripts, and that would be in the year 2021.